Hello, everyone out there. Welcome to our live stream discussion. Today, we are talking about WebAssembly and how WebAssembly is going cloud native with the news of wasmCloud joining the Cloud Native Computing Foundation as a sandbox project. I want to introduce myself and my co-hosts. I'm Alex Williams, founder and publisher of the New Stack, and I'm joined by Daryl Taft, who is a senior news editor at the New Stack. Nice little horn there. I like that. I don't know where that came from, but that was a nice touch there. And also joining us is Mary Branscombe, who is a contributor to the New Stack, a frequent contributor and one of the best in the business, I'd have to say. I'm going to be here for a minute, and then I'm going to leave and let Job Jackson take the mic here. So I want to just get started, though, by everyone making some introductions. And so I would love it if, if you can see me, I'm in the upper left corner, then Mill is Daryl, and why don't we just go around the horn from there clockwise? So go ahead, sir.
I think that's me. Hi, I'm Tyler McMullen. I'm the CTO and co-founder of Fastly.
Yeah, I'm Oscar Spencer. I am a software developer at Suborbital Software Systems and the core team lead for the Grain programming language.
Great, Mary.
Oh, Mary Branscombe again. I'm a freelance journalist. I've been doing this for a very long time. And I was such a WebAssembly skeptic until quite recently. So I'm really excited to see where it's getting to right now.
Great. Matt?
I'm Matt Butcher. I guess I'm the opposite of a WebAssembly skeptic, a WebAssembly optimist fanboy. I don't know. I'm from Microsoft. I lead the Deus Labs team, who's done stuff like a lot of cloud native stuff like Brigade and Helm and Draft in the past. And these days, we are just kind of all in on the WebAssembly story.
And I'm Luke Wagner. I helped start WASM a while ago at Mozilla, but now I'm at Fastly, working on WebAssembly standards and evolution.
Connor?
Hi, I'm Connor Hicks. I'm the founder of Suborbital and creator of the Atmo project and several other WebAssembly related things.
And Liam?
Hi, I'm Liam Randall. I'm co-chair of the KubeCon NA WASM Day. I'm the co-founder of wasmCloud and the founder of Cosmonic.
Excellent. Now, I'm going to turn over the discussion in just a second, but I do want to give a little overview. And then, Gerald, I'm going to turn it over to you. Now, we know that WebAssembly is one of the most talked about developments in software engineering circles. That's definitely seems to be the case over the past several months. But what is making it impactful is now only just getting to be understood. And so our goal here is to discuss WebAssembly and get a sense of what it is, the use cases, and the prospects for it over the next few years. Now, for a little background on WebAssembly, it was developed at Mozilla. It seemed to be, at first, just a nice sandbox technology for web browsers, but instead of relying on the cumbersome JavaScript, programmers could write features in their favorite programming language and just enjoy it and have fun. The code was secure, had lots of other features. Because it was fast, you could be compiled into bytecode. But then WASM, as it's well known, started to be used in the outside world quite a bit, and that's kind of what I think is propelling it to where it is now. And so now this week, the Cloud Native Computing Foundation has accepted the WebAssembly runtime as a sandbox project, and now there's more efforts to make WebAssembly usable across a lot of different hardware platforms, including ARM, and that is called the WebAssembly System Interface. And so there's lots of action in movement. Now, one of the things that we do want to talk about then is how it's going to be used beyond the browser. And so we'd love to hear that from our group today. We really want to encourage you all in this group to have a nice conversation. I'm going to now turn it over to Daryl to get the conversation going. Daryl.
Okay. So I have to admit, I'm new to WebAssembly. I think I've known about it for like 10 days, but I was lucky enough to get indoctrinated by some of the best in the business, apparently. Spoke with Luke and Tyler, also Matt and Liam, and they gave me so much stuff. I came away with like 3 or 4 stories. So I'm interested in the beginning, but we've got an hour, so I mean, there's so much to go over. But Luke, could you go back to, what was the pain point and what were you trying to address when you guys developed this thing?
Yeah, happy to. Yeah, so going back, remember, plugins used to be how you did stuff in browsers that wasn't supported yet by HTML or JS, and browsers decided we really wanted to get rid of plugins. They were a major source of security vulnerabilities and performance problems, and they weren't standards, and they weren't portable. So a lot of work was motivated by that. So all the work on like video tag and audio tag and WebRTC addressed a lot of the use cases. But for the general case, when you're just running general kind of like 3D code, like the Unity plugin was a really big plugin. What do you do? So we needed something that was sandboxed and lightweight and kind of fit in within the web. And so, yeah, that's how we started working on WebAssembly. And it's a very incremental path. We started by compiling things like C++ to JavaScript, which sounded pretty goofy. And then we made that faster, and then we saw how far we could push that. And that was wasm.js. And then we were like, but are we done here? Is this the best we can do? And so with all that motivation and preparatory work, then we got to start work on WASM 2015. And then 2 years later, we had a standard that was in 4 browsers. And at the beginning, we knew it needed to like solve browser use cases, but there was this agreement that it shouldn't be hard. There shouldn't be a hard dependency on only running in browsers or only running when there's a JavaScript, when it was embedded in JavaScript. So we made this kind of decision to not bake in dependency on those things. And we did that kind of looking at JavaScript, which had, been created in a browser, but it was being now used in like Node.js outside of the browser. And we're like, well, people might want to do that with WASM. We weren't sure whether anyone would want to do it, but we wanted to at least allow that to be possible. So it's a great surprise to see what people have really actually wanted to do with it outside the browser.
Yeah, well, that's one of the things that I'm mostly interested in is use cases, but I'm also interested in, what is it that you guys saw that attracted you? I mean, what was revolutionary about this technology that you said, we got to use this?
Yeah, this is Liam. My perspective was from working at an incredibly large enterprise that had not just handfuls of services, but fleets of services. So following the tradition of JavaScript and Node that Luke had started to mention, WebAssembly seemed like a very natural target to transition from a browser-only technology to the server side. And when you look at the problems that enterprises face for the next 20 years, we're always confronted with this reality that we can't solve the problems of tomorrow with the technology of today. And enterprises today are really facing 3 gigantic problems and opportunities when they're looking at the future of their applications. The first is that the future of their applications are dramatically distributed. When you're looking at needing to support not just different CPUs in the data center now with the rise of ARM, which is a cost savings opportunity, but a long tail of execution platforms that include the web browser, but transcend it into end user devices, we need to start thinking about new formats and containers that don't embed assumptions, for example, that you're going to run on Linux or that you're going to be compiled for a specific CPU architecture. So as a fundamental technology, WebAssembly's security and portability really unlock a ton of opportunity for the enterprise.
Yeah, and if I might jump in there, I think a lot of the things that attracted us to WebAssembly were the things that made it a good fit for the browser. The idea, the promise of WebAssembly in the browser is you could take these untrusted pieces of code and run them safely without worrying about them, being able to perpetrate madness on your system, right? And in the cloud world, coming from the Azure approach, we had virtual machines that solved one set of problems. And then we had containers that solved another set of problems. But we had this other category where we're going, how do we get these sort of binary cross-platform, cross-architecture pieces that can be lightweight and moved all over the place, very fast, scale to 0 and scale back up without anybody even noticing what was going on. We've got this bucket, what's the technology that fits? And WebAssembly really, it really fits that particular bucket, right? Its performance profile is great, its security profile is great, binary sizes are great, and that's the thing that really has us excited about WebAssembly and how it can kind of fit a niche in the cloud native ecosystem that exists today.
Yeah, and I'll hop in here and say, from like Fastly's perspective, our goal was building an edge computing network from the earliest days of the company. And so when we finally sat down to try to build a more general purpose version of this versus what we had built in the early days, we looked around at the technology and we're like, well, okay, so we have a relatively large set of problems, which was actually covered by several people already. But what it really came down to for us was like the ability to have multiple languages, the efficiency and performance aspects of WebAssembly, and then also the security side of it in particular. When you're running code at the edge, when you're trusting someone like an external entity to run your code for you, you really have some pretty strong security requirements, especially for the types of companies that we support. But the performance aspects of it were one of the biggest ones for us, right? Because if you're using an edge computing network, one of the primary things, probably the primary thing, is performance related, it's latency related. And so being able to provide the ability to start up and run code with essentially zero cold start time was pretty important to us. And that's something we really couldn't do without something like WebAssembly.
Yeah, and for me to chime in from a programming language author standpoint, honestly, WebAssembly is sort of a dream. You have this new platform where you can have a language that compiles and can run on all sorts of devices, right? Like, we're not just talking about, running in the browser. If you want to run on microcontrollers, if you want to run on the server, it's just going to happen. You don't have to, as everyone's done so far, compile to LLVM. You don't have to do that. All right, in the case of the browser, you don't have to compile to JavaScript and inherit some of the semantics of JavaScript along the way. You actually have something brand new, something fresh. And building a compiler, in the era of WebAssembly has been absolutely incredible. And I think we're going to see a lot more languages start coming through and targeting WebAssembly as well.
So for the developer, there's a lot of inherent reasons to think about writing to WebAssembly rather than whatever particular specific. Well, you're going to use your language, but there are additional advantages that come with WebAssembly itself.
So one of the things that made me start taking WebAssembly seriously around the end of last year, beginning of this, was the Bytecode Alliance coming together and kind of revitalizing the group of companies and projects that had been involved in this, and WebAssembly showing up as an extra day at KubeCon, which has always been a really interesting point of emergence. But here's a new technology that's so important, so interesting, that everybody who's paying attention to KubeCon might be interested in it. So I'd love to kind of get everybody's view on where you feel WebAssembly is in the maturity state at this point. Because one of the questions I get from people a lot is, well, it's been around for ages, but is it ready, and where is it going? And maybe we could kind of talk a little about where WebAssembly is in the progress to where it's going to get to.
Yeah, Mary, Tyler and Matt and Luke and a few others and I worked very closely together on planning, the integration of the WebAssembly Day into KubeCon. And we were very deliberate in the messaging and how we wanted to approach the topic, because WebAssembly was already showing up in three primary ways in the cloud native ecosystem. First, it was showing up as applications that were running on top of the stack. Second, it was showing up as a platform in its own right. And more along Tyler's use case, if you look at the Crustlet project that Matt Butcher's team has worked on, which lets you natively orchestrate WebAssembly. And then a third, a wonderful use case that Connor should probably speak to, is as a execution platform for running others' untrusted code. And this is where we see things like Envoy adopting it. And I would really want to emphasize and just start the conversation and say that while there are some trade-offs and some places where you would want to use just WebAssembly or where you would want to use just containers. Today, we find ourselves in this wonderful position of having a better together story, that WebAssembly is incredible and awesome, and so is Cloud Native. And together, they're even better. I would maybe, Matt, do you want to maybe speak to some of the platform use cases with Crustlet and some of the things you guys are working on?
Yeah, sure. An interesting way to start that would be to say, when you think of Ruby, what do you think of, right? And for a long time, I think it was 10 years, Ruby didn't have really a real firm story, but it was there and it was mature. And then Rails comes along and all of a sudden there's this huge boom in Ruby development. And I think, and Luke, of course, could speak to this more. WebAssembly was there and is rock solid and has been deployed in all the major browsers. But for some reason, what I think of the critical WebAssembly story didn't necessarily, or so far hasn't showed up necessarily in the browser, but in these platform areas, right? And, we're looking at Kubernetes, for example, and my team's been doing Kubernetes for a long, long time. And we were starting to hit areas where Kubernetes, the clustering technology was a good fit, but the container ecosystem was not quite hitting what we needed. We had this conception that maybe we should be able to extend the cluster outside of the data center and say a cluster isn't something that sits, up in Azure or in your physical, on location data center or anything, but something that sort of permeates out into all the devices that you want to be able to control. But the problem there was that containers are very hard to build in such a way that they're cross-OS and cross-platform. And so we started looking at ways to integrate the WebAssembly technology into Kubernetes. And we said, okay, well, we can take a node, and instead of having the node run a container runtime, we'll have the node run a WebAssembly runtime. And Kubernetes has all these great mechanics where it was fairly trivial for us to say, okay, now that we've got that, when you declare your pod definition, just declare it this way, and Kubernetes will figure out, oh, this needs to be scheduled onto a WebAssembly capable node and run it there. And that's immediately kind of given us traction on this story that maybe only a year and a half, 2 years ago, we were thinking was sort of pie in the sky. How are we ever going to get a cluster to extend out to these small embedded devices? How are we going to get it to extend out to the edge? How am I going to get it to extend out to my phone? And WebAssembly is proving to be a language that unlocks an entire layer of platforms that we'll be able to build.
Do you see WebAssembly taking over from containers entirely, or are there still two separate domains?
Oh, I think they're going to end up being two complementary technologies. And I earlier talked about virtual machines, containers, and WebAssembly as three kind of different categories that we sort of have seen. And when containers first came on the scenes, I remember being in the first and naive wave of people who were going, watch out, VMs, we're going to wipe you off the planet now. We got containers and everything's going to be awesome. And it turns out that most of our container runtimes now run on virtual machines, right? There's a certain amount of everyone's got its own strengths and weaknesses, WebAssembly included there. And I think that what we'll see is complementary stories will begin to emerge and are very rapidly emerging, right? Where we will want to run our databases on containers and we'll want to run our existing applications. Many of them will want to be on containers. But when it comes to microservices, I think WebAssembly is going to make big inroads into microservices because we can make architecturally simpler, architecturally more resilient applications in WebAssembly. So I think you'll kind of see workloads chunk out depending on the technology that becomes the best fit for them.
That's funny. My shorthand for describing those the difference between those three for a long time had been basically like a virtual machine is emulating a computer, a container is emulating essentially a private operating system, and a WebAssembly instance is effectively emulating a process running on a thing. That said, I think that one of the novelties of WebAssembly is the fact that it is so much more flexible, right? You can run it in tiny things. You can run it in much larger things. It doesn't have to be constrained in quite the same way that I think a lot of the other technologies have been.
Yeah, well, Tyler, if we think of the continuum of really tiny devices, like let's say a light bulb, through phones and automobiles, all the way up to public data centers, there is going to be some lower bound where either we're not going to be running Kubernetes or we're not going to be on a Linux device. And to that end, the two biggest platforms that I would point to as the reference use cases would be iOS, which is a non-Linux operating system, as well as the web browser, which to me really feels equivalent from a where I want to run code to some arbitrary CPU or some data center device. It's just all one sliding continuum. And the fabulous thing about WebAssembly is that because it's an open WC3 standard, it's a shared resource, you can even have engines that are tuned for different ends of the spectrum. At the high end, we might have engines that are tuned for taking advantage of machine learning chips, features that are baked into big silicon like WASM. Down at the lower end, we might have engines like Intel's WAMR that are optimized for low power or low resource usage devices. So it really does give us a whole new platform. And I genuinely believe that the next epic of computing will be based around the WebAssembly, with WebAssembly at its foundation.
And I think that Luke's vision of what WASI could be really will flesh out kind of these concepts, because I think we're talking a lot about the flexibility of WebAssembly and the way it can run here and there, but it's WASI, I think, that's going to make that story happen.
Now, Matt, perhaps you could talk about what WASI provides. From my understanding, this is the true cross-platform aspect of it. The WebAssembly system interface, yeah.
I'll let Luke for sure answer that.
Okay.
Sure, yeah. And this kind of speaks to like where in the maturity spectrum is WASM. Like it's being used in some places totally in production, and it has everything it needs for some use cases. But for other use cases, there's a lot of things that are kind of missing, because you could say, what is WASM? It's a kind of I think it was like a standardized instruction format. That's great. So I gave you like an open standard like chip, but what do you need to like run real workloads is you need more than just a chip. You need like a whole operating system and software ecosystem around it, a bunch of tools to produce this, places to run it, and what are the interfaces. So we kind of started realizing, I guess 1 to 2 years ago, I forget exactly how far, is we need more. We need more standards than just WASM. We need, how does WASM talk to like the outside world? And so, we started this WASI effort, and at the beginning it was like, well, we should kind of just WASMify like POSIX. And so we took the closest thing to that already existed, which was Cloud ABI, and said, okay, that's where we're going to start from. And then we started kind of enumerating like, what are our goals here? Like, what do we want this to be like? I mean, do we just copy POSIX exactly, or is a WASM module just like when it runs? Is it just like a process, and does it talk with pipes and other normal processy things to other WASM processes? And so that's kind of where we started. But then we started, looking at like, what are the strengths of WASM? What makes it unique? Like, why would somebody choose WASM and not do one of these existing established technologies that's like already really good? Like the JVMs are really good at being JVMs, and containers are great for what they are for, and VMs too. So what's like the unique value that WASM's bringing here? And I think it's this really lightweight, ephemeral execution, this lightweight guest sandbox for guest execution of code. That's kind of the new thing. We can put WASM in newer and smaller places. So let's lean into that. Let's try to make a model that embraces that. And so no, these little WASM instances, they don't have to be whole processes. They can be something much smaller. So this kind of vision that we initially started just as sketching, like what are the properties we wanted to have, was this nano process model that we blogged and wrote a great post about, that excited a lot of people and got a lot of people talking to us and participating. And so what we've been working on for like the last year is, well, more concretely, what is a nano process? What concretely, how do these things work? What does it mean for a tool chain to produce, a nano process? What does it mean to run a nano process? How do they talk to the outside world? And so we have some standards now that are solidly in progress and being implemented and prototyped and used by people in this call around this. And so what it's starting to shape up is a set of standards that we're calling now like the component model, which is saying we need some sort of unit of WASM that has a very clearly defined interface with the outside world. And whereas it's WASM in the middle, it's, as the machine code, when it talks to the outside world, we don't want to be speaking these low-level WASM types. I don't want to be passing like just a bunch of I32s and pointers to memory. That's very low level. It's what you want if you're a compiler, but it's not what you want if you're using this from the outside world. I want to see high-level types and signatures. Like I want it to look kind of like, say, OpenAPI, or I want it to look like I have an interface. And so we've been defining one thing as interface types, which are high-level types, things like lists and records and variants and all the things you build high-level interfaces for. And handles, like abstract things where I'm not copying the value, I'm giving you to handle it, and you can have operations on the handle thing. And once you have these types, now you can start defining language-independent interfaces, which is what we wanted to do for WASI, which is like, okay, I want to interface for file systems, or interface for streams, or interface for HTTP is a really big, important use case that we're working on now. How do I define these interfaces in a language-agnostic way? Because WASM's language-agnostic, so should WASI be. So how do we define those things? And so that's the interface give us the types to talk about these language agnostic interfaces. And then as soon as you have those, you're like, okay, well, one thing processes do is talk to the system, but the other thing is they talk to other processes. Do they talk through pipes or sockets, or like how do these things talk to each other? How do I take two modules and compose them to make one compound module that from the outside world is just one thing? How do we have composition? And WASM has modules, which makes people think it already has this compositionality, but it doesn't, or you can't do it from within WASM. The way we get away with this in the browser is that you have JavaScript and web APIs, which like fill in all the gaps. You can like do anything you want because you can always drop down to JavaScript who can wire up all the things. But if you're outside the browser and you don't have JavaScript or web APIs, you have to like invent a solution for this. So our other proposal is called module linking, and it says how does one WASM module import and then create and link together a bunch of other WASM modules, and how do I use that to build whole applications that are built out of small nanoprocess-like modules? So those are the standards efforts that are in progress that collectively form what we're calling this component model. So hopefully what that'll give us, the WASM outside the browser ecosystem is this kind of clear standard, open standard definition of here's a component, here's its signature. I can now publish this and consume it without knowing what language it is, without knowing what toolchain produced it. And I can drop it in, an edge compute network, or in, a cloud compute network, or inside of a database, or inside of all these exciting places people are running WASM.
Yeah, this idea of components is something we've been exploring quite a lot with our Atmo project. We think that taking many small components of your application and stringing them together, composing them together to form the overall business logic of what you're trying to ultimately build, which is a web service or a web application or something like that, is a really powerful notion because you can move it. You can have something running in your centralized cloud provider and you can shift it to an edge network if you need to. You can have it be a lot more flexible and a lot more modular than code is today. Even with microservices, if we make the unit of compute smaller, like a function, rather than an entire server or entire application, we can be a lot more flexible and allow our applications to be more polyglot, have multiple languages all working together to achieve our business logic.
It also says something about the way that these things can be deployed and actually run in a production environment. Right, like the flexibility of an approach like this means that, yeah, you could essentially run these as two different processes and have them talking over a pipe and translating on both sides. You could have them running on two separate computers. You could have them running in the same process and actually just talking over what to the computer just looks like a straight up function call. It's really like, again, I hate to harp on it so much, but like it's really the flexibility of WebAssembly that like gives it so much that brings things that like haven't really existed in the computing world for a long time.
Yeah, I think that the microservice architecture taught us a valuable lesson, right? That if we can control the size of the chunk of code that we're working on, then it'll lead to, fewer security holes, better developer experience, more easily maintained code base. And these are all good, right? A good, hygienic, stable code base is good. But then we were always building the same chunk of infrastructure every time, right? We had to stand up an HTTP server. We had to unmarshal and marshal or decode and encode our data in and out of JSON or YAML or whatever data formats we needed to use. And we took a network latency hit every single time, and you layer in authentication and SSL, TLS, and before long, you've got the milliseconds are starting to add up, the code weight is starting to add up, the attack surface area is starting to add up, and all it takes is, a bug in one of these core pieces, and suddenly we have to patch 1,000 different pieces of software because of a 0 day, right? And this idea of the nanoprocess model is compelling to me because we're eliminating that layer of cruft along the edges, and we're really getting to the heart of what the microservice architecture was supposed to be about, right? Was just focusing on that one thing that this code was going to do well. And we didn't have to worry about the HTTP layer anymore and the serializing and deserializing of JSON data and the authentication stuff. All of that gets relegated to the WebAssembly runtime platform. And for me, coming from this kind of practical cloud perspective, this is yet another one of those aspects of WebAssembly that I think is just awesome. And I think you see with both Atmo and with wasmCloud, along with the emerging stuff coming out of Bytecode Alliance, these different programming models that are starting to emerge that will help us take advantage of those kinds of design patterns more effectively.
Terrific, terrific. I know we've been getting some interesting user comments on the YouTube channel, and one of them is about the idea of federated microservices. That's something I haven't heard before. But Connor, perhaps, Connor, by the way, we have a number of stories on the site about WebAssembly today, including the wasmCloud announcement. But he wrote a piece for us on the 3 pillars of WebAssembly, and that's getting a lot of reads now. So, Connor, I was wondering maybe you could talk about the microservices aspect with Atmo.
Yeah, for sure. So Atmo is designed to take away a lot of the burden that you see today when you're trying to build microservices. And we actually started this project based on containers and found that they weren't the right tool for the job, which is what pushed us towards WebAssembly and WASI. And what we're finding is that when you are bootstrapping a new service or a new project, you're trying to start a new application of some kind, there's so much boilerplate that you need to put up front when you're building this application. So we asked ourselves, how can we remove a lot of that front load work that you normally have to go through every single time you create a new Git repo? And that led us to moving a lot of the logic and a lot of the orchestration out of the user's code and into the underlying platform. And once we made the pivot to base this on WebAssembly, we were able to do an incredible amount of work behind the scenes that the user no longer needed to care about. So when you talk about shuttling data over the network, creating meshes within your data centers, and handling different protocols and marshaling, unmarshaling, all these kinds of things, a lot of it can just be done by the host, and you have just these small, independent pieces of code that perform a very specific function. And we see all sorts of different iterations of this across different cloud providers. You've got Lambda, you've got Google Cloud Functions, all these kinds of things. But WebAssembly gives us this wonderful open source version of these platforms that we can take advantage of in any way that we see fit. And so the Atmo platform allows you to build these applications and have all of the benefits of microservices, the scalability and the beautiful code bases, without needing to care about all this boilerplate underlying logic, all of the networking, all of these things. So WebAssembly is really a means to the end of having better distributed systems and better code bases in general, I think.
Nice. Mary, you've been talking to the analyst community about the impact that you're seeing, and they seem to be tentatively positive. What are you hearing out there?
So the analysts I've been talking with, well, I've been having two separate kinds of conversations. One is the venture capitalist and investment community who are very, very bullish on WebAssembly, and it feels like there's an awful lot of money going to be moving into this space over this and the next couple of years, and that's in acknowledgement that this is a thing that is starting to build and that is going to develop. And what I'm hearing from some of the analysts I talk to is that they view it as being at the very early stages, which makes sense. You want the investment at the early stages. I look at the number of WASM runtimes that are out there, and it's like the Precambrian explosion. I started making a list and I got to like 7. I'm like, well, is this a runtime or a platform? And every time I looked at it, there were more and more of them. And even the Bytecode Alliance has 3 runtimes that they're converging down to 2. And we're going to get this explosion of investment and development and new tools and new platforms and new ways to try things. And then coming along behind that, we're going to get the major adoption and the enterprise adoption. And the analysts I'm talking to are saying that is still being some way in the future because of how much of WASI is still experimental, and particularly nano processes, and some of the really exciting things that we're going to get that are still I was talking to Matt Butcher about this just the other day, and I think you said, Matt, it's the POSIX way of doing this, the Unix way of doing things. We build a tool to do A that lets us build a tool to do B, and then we put those together to do C, and that unlocks what we can do with the next of them. And we're just at the kind of A going to B stage, is what I'm hearing.
Yeah, I think that's, and I think it's interesting too, that if you start seeing VCs funding something and then analysts starting to turn cautiously optimistic that in the future this might be something, those are the same kinds of signs that I think you tend to indicate that there's something there to be had, right? But that stability, an enterprise doesn't and shouldn't move to a platform till it hits a certain stability metrics.
Matt, I think what's interesting about WebAssembly is that it's the technology that people are adopting from an enterprise perspective, whether they have a strategy for it or not. Because WebAssembly is showing up already integrated into projects throughout Cloud Native, and the sort of developers are just making the choice. I mean, this is not a niche technology that's supported on a handful of devices. This has full support across all the major browser runtimes, which makes it an attractive target for in-browser computation. And with a variety of different WASM runtimes, it's inevitable that we would start to see these things in production at servers on the really small end of the scale where Kubernetes and Linux may not be an option, as well as the large end. At the upcoming KubeCon NA WASM Day, we've actually carefully curated some talks to try to provide examples of both. We'll have somebody talking about Sony will be doing a talk around running things on ESP32, a very small chip. And we also have a large UK bank that's using a wasmCloud in a multi-cloud server scenario for resiliency and redundancy. So we've really tried to fill in the continuum here to help inspire people about how WebAssembly is already being adopted and deployed into production by enterprises throughout the world.
Yeah, allow me to partially walk back then and say that WebAssembly itself is like Ruby, right? It's been stable for quite a while. It's those tendrils out on the outside where some of them are stable, some of them are unstable. But the ecosystem as a whole, I think, is just now at that point where I think analysts look at it and say, yeah, I see possibility there. I'm going to wait it out for a little while and see when it really, catches on.
As I've been looking at WebAssembly over this year, there have been these periods when I've been surprised by something, and I was surprised by JavaScript making a fundamental change to the language that almost directly contradicted the philosophy that JavaScript had always had of you don't have to care about garbage collection. You will never think of that as a developer, to actually put that in as a fundamental primitive in the language explicitly to support WebAssembly. And one of the other ones that surprised me was when I found out that Flight Simulator has punted on the entirety of the complexity of DLLs, and they run WebAssembly. They have WASM modules where you would expect DLLs because it solved so much of their issues. And these kind of point use cases are fabulous. And I look at KubeWarden and I look at Open Policy Agent and Envoy adopting WebAssembly where you would have had Lua or you would have had a complex scripting engine, and those point things are really always interesting and surprising. And I think what I'm hearing from the analysts is the same as Matt is saying, that you've got these places where it absolutely works, and then you've got this really big promise, because there are so many fundamental things that WebAssembly does right that we haven't done right before. Off by default, denied by default security, going right down to kind of, fundamental primitives of how you put a language together and how you develop a system. And with WASI doing this really interesting thing of you have the operating system primitives that WASI is providing, but then WASI interfaces are also high-level things like neural networks. And it's such an interesting mix of ideas that we've had for ages that are coming together, being brought forward and being done really, really well in WebAssembly. That is the bigger potential of it that gets adopted in the long term.
Yeah, I think as we're starting to look at a lot of the tooling that we have in WebAssembly, it's getting better and better all the time. And I think, especially if you look, 3 months from now, 6 months from now, 1 year from now, we're going to see a lot of really fantastic tooling. For a lot of the tools that people already love to use, like Rust, like C, the tooling is there for folks to go forth and build all these things. In fact, the way that you're able to say, hey, I don't want these dynamic libraries. I just want to start doing everything in WebAssembly. That's because we have C compilers and we can take existing code and bring it to WebAssembly already. So as other languages are starting to catch up, as we're seeing new languages on the horizon, we're going to see more and more coming. So I think everything that you're seeing is absolutely right. This is definitely going to be the future, and the tooling is just getting so close.
Yeah, and one last thing I'd add is I bet that over the next couple of years, WebAssembly is actually going to fade into the background. It's going to become so commonplace. It's going to become such a commodity that you're not even going to notice you're using it a lot of the time. Same way that most developers don't need to care about the assembly or the machine code that is generated when they compile their code. WebAssembly is just going to fade into the background in that same way. But because it has these inherent benefits of its security model, of its performance and portability, we're all going to be getting this wonderful new set of capabilities that we just get for free because of the format that your code is being output to.
I'm actually really glad you mentioned that, Connor, because this is something that Luke and I actually talk about on a regular basis. We actually view this as kind of a success metric for WebAssembly. Like we will know we have succeeded when it fades into the background. Like that is kind of the goal here. Most people should not have to think about a lot of these like lower level details, right? That also kind of like is a good intro to like what the Bytecode Alliance is about. Like one of the major goals of the Bytecode Alliance was kind of augmenting all of the standards work that is going on for WebAssembly itself. Like a lot of the standards work are about the language itself and like the type systems and so on that go with that. What the Bytecode Alliance has always been about is about the tooling that you use for that. Like we're trying to produce really solid kind of standardized tools that people can use. And again, with the goal of a lot of those lower level details just kind of fading away into the background for most developers.
And I think Oscar highlighted the advantage of being able to compile C to WebAssembly, Rust to WebAssembly. The litany of languages seems to be growing every day, right? Swift, and then, but I think it's interesting, Oscar, that you've basically opened up what I think is going to become a very popular, if not the most popular, scripting style language for WebAssembly, which is Grain. My team's been using it more and more these days. And I'm actually curious why you chose WebAssembly as sort of your basis and sort of what the inspirations were for that language and where you kind of hope it goes. Because to me, it represents sort of like the promise of new development languages that are going to enter this space.
Yeah, absolutely. I mean, the early days, the very beginning was WebAssembly was on by default in all browsers. And all of a sudden, hey, we have a brand new compile target. No longer are the days are we, having to only do ARM, only do x86. It's like, hey, I have something brand new. Hey, it's secure. It's going to be sandbox. It's going to be portable. It can run on any single platform. And this was the sort of light bulb moment for me and the other folks in the beginning was, oh, hey, we can actually build a language that folks are going to really want to use. Nothing against languages like C and whatnot, but a lot of developers often are a little bit scared of these languages. And so having the opportunity to bring a brand new language that's really, really high level, like I like to think of it as saying like, oh, I want it to be that Python-like language, that Ruby-like language that folks are using on WebAssembly to really be as productive as possible from the get-go is, I think, why folks are starting to use it more. And like you said, we're going to see more and more tooling just like this. Because, yeah, in the early days, it is going to be very low level. But especially when we start looking at interface types where, in the future, maybe there's some really intense math library that's written in C that we want to bind to in Grain. Using interface types, we'll be able to do that. Using module linking, we'll be able to do these things. And as these proposals are rolling out, and I keep my eye on them pretty darn hard, as these things are rolling out, we're really on top of it and getting it in as quickly as possible.
Nice.
And that's why we're going to see, so much development.
Hey, what is Grain? Where did it come from, and what's its deal?
Yeah, so Grain is a high-level programming language. It has ML roots, so think OCaml, think Rescript, think languages like this, maybe Haskell, whatnot. But the idea is to have really, really high-level sort of computational language. Like, we shouldn't be thinking about garbage collection, so waiting on that garbage collection proposal to drop as well. We shouldn't be thinking of, you know, pointers and whatnot. We should just be doing code. You should be feeling like, hey, I'm writing Python, I'm writing you know, maybe in the future writing some really high level Rust where, you know, maybe everything's all macros. And that's what Grain is all about. Grain is all about being that high level language for WebAssembly.
Nice.
Yeah,
nice.
the learning curve on it, I think I was productive in the language within a couple of hours. It's a lot of fun. It's a fun little language. Is it grainlang.org? Is that where you go?
Yep, grain-lang.org.
Well, right. Matt, Oscar's been talking about tooling, and you guys are the masters of tooling. Is Microsoft working on anything in the tooling arena around WebAssembly?
Yeah, I think probably all of us in the room are trying to figure out what the developer experience should look like, because at the end of the day, WebAssembly is a compile target from the perspective of the developer, right? So how do we really streamline that process of building something, compiling it, putting it somewhere, and then executing it? And you know, we've been piloting all kinds of fun projects. You know, we talked about the Waggy project. Mary and I talked about that earlier, where we basically said, all right, given this, the status of WebAssembly today, it doesn't have networking fully finished. It doesn't have the WASI spec is still moving. What can we do today that would start to open people's eyes to how easy this should look? And we built this program system called Waggy that's a simple runtime. You stand it up, it listens for HTTP requests, and it executes your WebAssembly modules using the CGI specification from 1996. And the whole idea there was to say, look, we can start writing these applications now, exhibit a lot of the strengths of WebAssembly, the speed, the startup time, the size of the binaries. But it's been an experiment for us just to start to dip a toe into the stream and see how it's going to go. I'm really, really excited about the work that Bytecode Alliance is doing, that Luke is pioneering with being able to link multiple modules together, the WIDIX specification for describing what a module needs and what a module exports. These are going to be fun things that are going to fundamentally shift the developer experience for WebAssembly. And we've just tried to give you something today that you can experiment with and use it today. But tomorrow's the exciting stuff.
So Matt, back at the last WASM day, you did that really good presentation about the Wild West of WebAssembly tools and the tumbleweeds rolling down the street. How far have the tools that you talked about then and the things that you were hoping to see come through in WebAssembly tooling arrived, you know, in time for the next WASM day?
It's a dangerous thing to speculate about the stability of this stuff that you're involved in doing on your own, because we always overemphasize how stable we think it is. But the ecosystem is definitely evolving rapidly, and there is still a sense of the Wild West, and it's a very exciting a time because there are so many opportunities. I mean, Suborbital and the Atmo platform is doing things in what I think is a very novel way as far as server processing construction. On the other hand, wasmCloud and its actor-based patterns, also a very exciting way of doing things. And each of these platforms is stabilizing pretty rapidly. So I think we're making progress. My big fear, and the thing I think most passionate about in general on WebAssembly, is that as we each are sort of exploring all these different, I think I called them tendrils before, as we're sort of exploring these things, we want to make sure that at the core, we're all kind of moving together, right? Liam used the phrase better together, because really what we want is a specification that's rock solid that we can all leverage for those bazillion different WebAssembly runtimes. And we want to start building a way of sharing libraries so that you don't have to build HTTP for Atmo, HTTP for wasmCloud, HTTP for Fastly, but instead we have sort of a uniform base. And I'm really passionate. I think that's the one thing where if we do it really well, our time to maturity is going to be very low. If we each try and go about it on our own, then I don't mean to cast shade at JavaScript, but the early JavaScript days were rough because we had so many different competing implementations where each implementer was trying to claim core runtime as the thing that they were going to use to distinguish themselves. I think that we have learned our lesson better, hopefully this time, and that we will do a good job of working together as an ecosystem and trying to build something together with interoperability in mind from the beginning.
Yeah, Mary, you bring up a really great point, and this does remind me of our early days in the cloud native ecosystem. Initially there were actually multiple runtimes that were competing to be the sort of standard bearer, moving forward as the common layer. And here, with WebAssembly being an open WC3 standard, we definitely have a sort of shared rally point through the Bytecode Alliance and the incredible work that's being led over there around standards and ecosystem. So I think that so long as we are homed to the standard, we can avoid some of the painful things that happened. If you look at the Java community, for example, the whole J2EE just went in different directions and they were incompatible with each other, and the community itself suffered. I think this time around, we have a group of stakeholders, including the folks on this call. None of us are strangers. We've all been already working together. We collaborate on messaging. We collaborate on how we talk about making ourselves available to communities. And we collaborate on even how we're going to the existing nexus of the cloud native world and telling the better together story so we can together be the bridge to the future.
Because the thing that you get after every Precambrian explosion is you always get the editorial die-off of the things that are really well suited to the ecosystem. And those are the ones that you want to get investment in, but you don't want that to come with a lot of bad feeling and unhappiness, because, it should be a natural evolution. It shouldn't be an asteroid coming in and squashing all the dinosaurs.
This is such a vivid metaphor. I'm never going to be able to look at WebAssembly runtimes without imagining meteors smashing into them. But actually, I mean, there's something to that Precambrian explosion, the survival of and an idea of a survival of the fittest. One thing that's really interesting and that I think might be a first is that we're seeing different styles of WebAssembly runtimes emerge. Some are using an interpreter model and interpreting as they go. I think the WASM 3 and WEMR are both examples of that. Then we're getting some that use JIT style models and some that use ahead of time compiling style models. And, to my knowledge, in the past, a lot of times I, as the developer, had to know which of those runtimes I was targeting when I was writing my code, largely because the languages were specific. That's a really interesting aspect that I think justifies, along with having a strong standard, different differentiation among the runtimes is going to revolve around performance profiles, memory consumption, and things like that. I'm really speaking more in Luke's wheelhouse than my own, but it is something that we look at the benchmarks and go, oh, there's possibility here. There's a lot going on here that's very exciting.
Yeah, and I think just for different devices, different execution modes make sense. In some situations, you have this spend a lot of time up front, produce the optimal code and blast that out to n different places who can now all just run machine code. But it's not machine code that was produced by the developer a long time ago. It was made specifically for that particular host or cluster environment. So that's one of the spectrum. And then the other one is kind of what the browsers are, which is here's some WASM, run it as soon as possible. And so that's where you get the complex tiering situations where you have in browsers today where there's 2, sometimes now approaching 3 tiers of WASM execution, interpreter to baseline to optimizing. So, and so it's great that, you need a clear WASM semantics that says, here's how it has to behave. And it's up to you to kind of make it fast and specialize the performance to your host.
I've been listening to the conversation on YouTube, and there have been some comments there about the different things that everyone's been saying here. One is that, for one, what about Docker containers? They succeeded because why? It was simpler to use, but there was fragmentation there, and we saw it. It was actually kind of brutal. I reported about it. It wasn't pretty. So I don't see how you can just say, oh, we'll kumbaya everyone. We'll just kind of keep everything together here. I mean, you've got to like be able to think about these worst case scenarios. So what are those worst case scenarios that you're going to try to prevent?
I mean, the absolute worst case scenario is fragmentation at the WebAssembly host runtime layer, because that's where we, the collective group of us all targeting a common runtime would not have a common runtime to target. So in wasmCloud, for example, we really try to only leverage features that are adopted and approved through the 5-step WC3 standard and supported across multiple host runtimes. However, I think that because we do have this common virtual CPU construct and a great steward that has proven themselves as a trusted a stakeholder, much like Google was with Kubernetes, the Bytecode Alliance team that originally formed at Mozilla and is now transitioned successfully to Fastly's stewardship is very well trusted as good stakeholders, good community members that really separate any nexus of business interest from the standard and what's good for the community as a whole. So I think this time around, having such clear leadership, whereas the last time around we sort of had a number of competing forces. And if you look at Docker's unfortunate outcome, they really cut their own throat in the way that they lost the trust of the community. Google, on the other hand, went in the opposite direction. They took the Kubernetes standard and it absolutely transcended every ambition they possibly could have had about what would make a successful orchestration platform. What metrics you would use to measure that. It even, in many ways defeated AWS's claim that they would only support, ECS in their own formats. Eventually, the consumers demanded portability and they wanted support for the standards across. And hence, we now have something that at least starts to abstract away from execution. And I think that is why those of us that have been through these sort of epics of technology multiple times have so much confidence in the future of WebAssembly. It's because we have such great leadership through the Bytecode Alliance and the team members there.
Yeah, I'd love to give a lot of the credit for this to those like early folks who were working together from Mozilla and Apple and Microsoft and Google, like specifically on the browser side of WebAssembly. Like we have really just taken that model that they had, where they would say like, this can't be standardized until more than a single browser actually supports it. And we've just kind of taken that and applied it to much more of the ecosystem than we have seen in the past, right? So I like to give them a lot of credit for I don't know if you've been around for quite a while now, like the idea of all the browsers working together in this way was like kind of surprising. And it's like, I don't know, set a pretty good example for the rest of the community.
Yeah, and I'll just second that. Bytecode Alliance does a lot of great work, but also just the whole W3C community group has just a whole bunch of active participants who are working, for the most part, really well together. And yeah, the folks at the browsers are still, doing really awesome collaborative work.
And I think that's therein lies the answer to the question, Alex, because I survived the container runtime debacle as well, and a lot of that was happening because we didn't have sort of a parliament of ideas that we were effectively sharing, right? We got into competition when maybe we didn't need to. A lot of this coming as a benefit of hindsight, learning that I had to do. OCI was a good step out of that, and OCI becoming a standards body where we could discuss and sometimes debate and sometimes, on occasion, I admit, yell at each other. But it gave us a room to do that, right? A space to do that. And I think W3 is definitely that kind of space already, and we've already got it. Bytecode Alliance is that kind of space already, and we've got it. If you show up to some of the WASI working group meetings, you definitely won't find Kumbaya, and you might find some very rowdy people who are very insistent that their particular way is the way, but we're all at least in the same room talking about it and sort of tacitly committing to saying, the outcome of this process, as arduous as it is the thing that we're going to accept as the way we're going to move forward. Hopefully that doesn't rule out each of our ability to innovate independently, but it establishes some kind of baseline where we can say, here's where we're all going to start, and we can each build, our version of Howl's Moving Castle on top of that.
Yeah, the idea to me is really like raising the low water mark, right? Like we don't want to compete about anything below this point. We want to compete about the stuff that's above this line, right? Like, and the idea is that as we go on, that line is just kind of growing and like rising over time.
Well, we only have really less than 2 minutes left. I do want to thank all our listeners out there who have been really participating in the discussion here. And I was just looking at kind of some of the other questions here. Maybe this is a good one from Lawrence Hecht, who works with us at the New Stack. He does a lot of research with us, and you might see his stories and him on Twitter. He wants to know really where was that? Let me see again where he said this. He said something about, well, first of all, he was asking about after cloud native, like, where do we think of things going from there? He said he cited one survey from JetBrain that really that there's not much of a what was it, participation at what level? Geez, I wish Colleen was here to help me out with this one. But maybe we just talk to more of the discussion about, cloud native is all the discussion right now, but in 3 to 5 years, it won't be really discussed as much. It'll be like, we'll probably be out kind of, thinking about the edges of the solar system, so to speak. It'll be a much different world out there. So how does WebAssembly fit into the, into that future, where, I mean, we're seeing kind of wholesale changes, for instance, in how we think about data centers and how we think about cloud services and how we think about edge environments. And so, so it's becoming much more distributed. And our definition of the new stack is services and software on sophisticated, fast, distributed infrastructure, and that can be anything at this point. So, just some thoughts on going forward. Mary, maybe you can start.
So the thing I've been hearing from a lot of people recently, I was talking to Brendan Burns about this recently, about what even is the cloud. And Microsoft has this phrase, Azure is the world's computer. And Brendan was saying that really resonated for him because, Brendan, co-founder of Kubernetes, is saying, yeah, the cloud is great, but the cloud isn't just in a data center. The cloud is one way of giving the world a computer, and the cloud at the edge, or whatever the edge needs at the edge, and whatever you need on premise, whatever you need on bare metal. It's how you bring the services together across all of those to give people the computing that they need where they need it. And I think cloud native will be inclusive of on an MCU in a light bulb with a WASM module that has a fast enough startup time to turn on as I press the switch and the light bulb turns on. So what I'm hearing is from a lot of people is WebAssembly is one of the ways we actually get to what you might call post-cloud native.
Can I throw another Brendan Burns quote in?
Yeah,
Brendan, because Brendan likes to say that distributed computing has gone from an advanced coursework to CS 101, right? That Docker and Kubernetes have opened the floodgates, and now we all think about distributed computing. I think, to your point, Mary, we've been talking about it as a thing that runs in the data center. And to me, the next evolution is going to be the idea that the cluster isn't a thing that lives somewhere out there, and the cloud isn't something remote, but it's the kind of thing that, I become the nexus of my own cluster, right? And the devices that surround me, that I have permission on, they become part of my cluster, and my compute gets distributed however it makes sense at that particular moment. When we talk about the promise of IoT and sensors and things like that, those should feed into this idea just as readily as being able to do machine learning at large scales or things like that. And my hope, sort of just to tack on one little thing at the end of that, is that in a sense, it'll also change some of the privacy model for us. Because when I become the nexus of my cloud and not something living out there, then my data is part of my thing and not necessarily something I farm out to somebody else to come up with information and feed it back to me and tell me something. So I'm really optimistic that that's really where we're going in the sort of the post-cloud native world, or maybe cloud native plus world.
We're over time, but I'm ready to, I can keep going another 5 so minutes, and if everyone else can, or if anyone has to run, they can jump off too.
I mean, I just wanted for a moment to go back to why we use the word cloud. It's because in the engineering diagrams of years ago, when you wanted to show how something got from here to there, and there was some complex thing in the middle that did the networking, you just drew a cloud because you didn't want to do a diagram what the complex networking thing in there was. And the fact that we said, well, those clouds are up there in the sky in the big giant hyperscale data centers, it was just the instantiation of that complex networking diagram that we didn't want to draw on the whiteboard. And what it looks like inside that amorphous nebulous thing that we don't want to draw is just going to keep changing as our needs and technologies change.
Well, those topologies in a distributed world are going to continue to be very ephemeral and dynamic, and I think that speaks to this sort of capability-based approach where, like with wasmCloud, you can simply attach the capability that you need at runtime versus make a decision at compile time. But there are a number of other compelling reasons that we know that the future of the world is distributed, and frankly, that WebAssembly is the future of distributed computing. It's not just the rise of CPUs and compute everywhere. It's making the dumb things in our lives smart and the intelligence that needs to run there. It's the system security, that there are compelling reasons, and I suspect regulation coming, that data will need to stay where data belongs, or not be transmitted through foreign countries or clouds. There's deliberate offline use where if you have your Tesla, not everything can be processed remotely. It needs to be processed locally on the device. And in the machine learning use case, the intelligence for machine learning needs to go where the data is. Think about a Nest doorbell streaming all video back to a cloud for processing. That's just not possible. It needs to have intelligence on the device that lives there. So there's a number of reasons why developers today are facing challenges. And if necessity is the mother of invention, then WebAssembly is the right technology at the right time.
Yeah, the way I like to think about it is in terms of layers, right? We are building out all these new complex systems that span central cloud, edge cloud, devices, IoT, whatever you want to call it. And we need new paradigms to span all of these different layers. And WebAssembly just happens to be a unit of compute that can be executed at all of these layers. And so if we can move past our current notions of, the cloud is the data center, then we can open up all these new types of topologies, all these new types of use cases. And WebAssembly just happens to be a really good tool to accomplish that.
I think that's super well said, both of you. This is kind of a thing I've been saying for a while now, is I think the really cool part about WebAssembly and an edge computing and a cloud environment is the fact that, you can run things. You can explicitly choose to run things in a bunch of different locations. However, one of the things that we could also allow is for things to move, right? They can move with the data. They can move to exactly where the most efficient place in the network is for them to be run, whether that's in the browser, in a database, at the edge, in your core cloud infrastructure, right? You can literally just move these individual pieces of computation because of the way that WebAssembly is made.
Oscar, any last thoughts before we leave? And then I'd love to get any thoughts from Luke before we go.
Yeah, absolutely. I mean, I think overall, what we're really seeing with WebAssembly is, a new revolution in the way we think about computing, honestly. And I get really excited when I think, through, what Tyler was saying, when I think about, I have some little bit of WebAssembly code that's running over here on the server, but, oh, hey, actually, this would be far more efficient if we just push that actual binary out to the edge. And that's something that we can do because our binaries are so small. We can just transport that code. It'll just work out there because we have the specification. So overall, I'm just really excited for everything that's to come with WebAssembly. And I hope, others, are inspired to keep building and doing more.
Luke, did you ever dream we'd be here at this point and now looking out beyond even, the concepts of the cloud?
This is beyond my wildest expectations. We were for a while unsure whether anyone would even care about it outside the browser. And Tyler was the first one who showed up and had a very concrete use case and said it worked great for it, and just kind of blew my mind. And this continually blows my mind, just how many interesting places people are finding to use WASM. And I love all the points people said. Moving code to the data, or just moving code to where it's closest to whoever's interacting with the clients, to wherever is the best place. That definitely seems to be the theme. Lightweight guest execution seems to be the theme, and it just surprisingly that use case shows up in a whole lot more places than just a browser. So I'm learning a lot just listening to everyone talk about all these different places they're thinking about running it. So very excited.
I want to thank everyone for taking the time here, and thank you so much to our listeners out there, and to the community on YouTube who has been very conversive in the chat there, and we've had lots of questions there. Someone should get back on anyone there. I think there was a question about Go in there. There was comments about federated microservices. I think there was a question back to Tyler about functions as a service and how it fits in the serverless realm. So there's lots there to, I think, converse with people. So thanks to everyone out there who did have something to say. The person who had Harshad Main says, I have a Golang bare metal server with a certain QPS. If I transfer the respective application to WASM plus WASI on same server, will it help to increase the application throughput? So that's just a taste of what we're seeing out there. I keep thinking about the latency issue. I look forward to exploring that more. But just overall, I think the conversation is just beginning to get started, and I've been waiting for something else to kind of rival container technologies as a discussion that has a richness to it. And this is really comparable just from my own journalistic perspective. So I want to thank you all for participating with us. We really value your time, and I look forward to following up and talking soon.
Thank you.
Thank you so much, Alex. Definitely another show in the future, I think, for sure, if not more than a couple.
Yes, great.
Sounds great to me.
Thanks, everybody.
Thank you.
Yes.